Hey everybody, my name is Mattel McKenzie, and today we'll be doing a skill builder speech on how plyometric training can help improve sprint speed. So, the best way to look at sprinting is in a pyramid, right? We have the bottom level, which is like more times than not the most important. Then as we go up more and more, although it may not be as important, it's still intricate to the building of the pyramid, or in this case, the sprint speed. So, starting off with the bottom, the base of the pyramid, we have the physiological foundation, right? The main thing with this is we have something called we have something called a stretch shortening cycle, or the SEC. There's 3 phases to this. So imagine this is the muscle, right? This is our leg muscle or our tendons. Usually it's the tendons actually. We have the loading phase or the eccentric phase, right? That's when we start to store power into our muscles. We're starting to load the muscles with energy. Then we start to go into an amortization phase, which is when the tendons or muscles start to stretch and they're actively storing energy and they're preparing to release energy. Then we have the co-eccentric phase or the explosive stage, where it's pretty self-explanatory. You start to explode, right? That's how we propel ourselves forward through the energy in our legs, in our feet, in our muscles, in our tendons, right? That's the physiological foundation. Next, the next part of the physiological foundation is the neural adaptations, what's going on up here. Because believe it or not, it actually takes a lot mentally to run fast physically, right? First things first, even though this is kind of physical technically, motor unit recruitment, right? So in our brain, we have motor units, right? And these motor units, they help us fire off, and it helps send signals to our body to basically tell us what to do, right? But the first part of this that's important is the firing frequency. How fast can it tell our muscles to contract, store energy, release energy, right? The concentric phase. Most people know it as fast twitch muscles, but this is basically because of the firing frequency of the motor unit recruitment, right? Next, the intermuscular coordination, right? How well can your motor units tell your brain, how fast can your motor units tell your body and your muscles to move your legs and your arms? How well can you move them together? Hand-eye coordination, as most people like to call it. That's the base of the pyramid, right? Next up, we have the middle of the pyramid, right? So this right here is the mechanical transfer to sprinting, right? We have the physical aspect of it. Now we start to get into the biomechanical part of it. The first things first that matters within this is our ground contact time, or our GCT, right? So this is how stiff our tendons are in comparison to compliance, or the ground. So how stiff will our tendons be when we land on the ground, and how fast will we release it, right? That is power and force that's being applied into the ground. We need force to be applied into the ground to run fast. Then after that, we have force application speed. How fast are you applying this force into the ground, and how fast are you able to release it to move forward even faster, right? The main thing about this is you have horizontal power versus vertical power. It's for 2 different things, right? Because when you're sprinting, there's 2 different phases. Well, technically there's 3 different phases, but the 2 main phases that most people think about is acceleration and your top end speed, right? Acceleration is when you're moving forward. It's when you're going from a standstill and you're going against inertia to move forward and go faster. So in order to do this, you need to be able to apply horizontal force. You need horizontal projection to produce power moving back into the ground to go forward, right? After this, we start to reach our top end speed. So when we're standing straight up and we're sprinting at full speed, that's basically what it is. This requires vertical force application, or vertical power projection. The reason why we need this is because we already have our horizontal momentum going forward. But if we're just going forward without going up and lifting, we're just gonna fall flat on our face, or we're gonna put our feet into the ground We'll put our feet into the ground in front of our hips and create a braking force, which slows us down. So a vertical force is required in order to sprint faster, right? And that's how you see people with the very fast top ends. Like if you guys know Usain Bolt or Noah Lyles or pretty much any fast person you know, more times than not, they're able to produce a lot of force vertically. The last part of the pyramid is the implantation and periodization, right? How much time can you put in between the workouts, and how do you structure them to be able to get the best productivity out of it, right? So you have extensive plyometrics, which is low plyometrics. It's when you're jumping, but it's not as intense, right? This helps to teach the muscles how to be able to store energy and be able to hold it in the amortization phase, which is the transition phase, and also the loading phase. Then after, you have intensive plyometrics, which is high intensity plyometrics. This is where we learn how to go from our transition phase or our amortization phase into the co-eccentric phase, which is the explosive phase, where we decide to put the power from our muscles that's stored and release it into the ground to be able to propel ourselves forward or vertical, depending on what we're looking at, right? Then after that, we have recovery and volume, because recovery is very important to be able to get faster, because our muscles need to be able to have time to recover and adapt. And without these adaptations, we won't be able to run faster, right? So our central nervous system, which is in here, well, not just in here, but it's within our body too, within our spine. That's what provides the motor unit recruitment as well, right? If our central nervous system is fatigued, we will not be able to run faster. No matter what, we will be slowing down. Our legs will not be moving as fast. We will be running with heavier muscles, more fatigue. We won't be able to hold our top end as much. We won't be able to accelerate as fast, right? But if you allow yourself to recover, you will be able to gain the adaptations from this. You want to be limited in how much you do per session, but pretty much if you train plyometrics, you will sprint faster. You will teach your body how to properly sprint, how to be able to load energy efficiently, and be able to let out the energy in a productive way that will allow you to run fast. Hence why plyometric training helps improve sprint speed.